Hi students, in the previous video I discussed with you how we can solve questions on analytical chemistry. Now in this video I will be discussing some more questions on practical or analytical chemistry. Keep watching. More questions on analytical chemistry, how we can solve. See this question, this is a different kind of question. The table shows the test a student performed on 4 aqueous solutions A, B, C and D. A student is performing test on aqueous solutions, 4 different aqueous solutions A, B, C and D. Write down on your answer script the observations 1 to 4 that were made. What are the observations? Okay. So here test 1, the solution A, barium chloride solution and dilute hydrochloric acid is added. Now the conclusion is A contains sulfate ions, SO4 2 minus ions. So what will be the observation? The observation is barium chloride will give white precipitate and the PPT does not dissolve in dilute HCl. These are the observations. 2 observations are there, right? Now in the second one, solution B, sodium hydroxide solution was added to it, right? And the B contains Fe3 plus ions. Sodium hydroxide or ammonium hydroxide and ferric ions will give nothing but a brown PPT. That's all, brown PPT. You write this much, you get a mark. Okay. Next question. See this question. Solution C is taken. Now ammonium hydroxide was added slowly till in excess. Whenever it says slowly in excess means you have to see 2 different observations in small quantity as well as excess, right? Now it says C contains cupric ion, Cu2 plus ions, right? So what will be the observation? Ammonium hydroxide is added slowly in excess. Okay, ammonium hydroxide first will give a whitish blue or pale blue PPT is formed, right? Now what happens? The PPT dissolves in excess of NH4OH to give deep or inky blue solution. So make it clear, okay? First you say whitish blue PPT formed or pale blue PPT formed. Then say the precipitate dissolves in excess of NH4OH to give deep or inky blue solution. Some students mix up things like whitish blue PPT, soluble PPT, or some people skip the first part, they say directly inky blue solution form. No, you make things very clear. First what happens in small quantity and then what happens in excess, right? I think it's clear. The next question is to solution D, silver nitrate solution and dilute nitric acid were added. What happens? Now silver nitrate, dilute nitric acid we are added. What is there? D will give a curdy white PPT. Curdy white PPT is formed on chloride and then dilute nitric acid is also added there. So the PPT does not dissolve. Okay, that's it on D. Then state what you see. Next question, next type of question is state what you see when a piece of moist blue litmus paper is placed in a jar of chlorine. Yeah, this we know, chlorine is an acid. So the observation here again 2 parts are there in the observation. The first part is blue litmus paper. Blue litmus paper turns red. And second part is the paper then turns white. This is important. Now you might be wondering what is happening here, why it is white. First thing is the acidic nature of chlorine. Okay, now I'll explain. This is not answer, is rough work. Okay, understanding. Chlorine reacts with moisture. See, it has to be moist blue litmus paper. See the moist blue litmus paper. Okay, it will give HCl plus HOCl to hypochlorous acid HCl. HCl will split giving H plus ion, so it will turn blue litmus to red. Now HOCl is unstable, will produce nascent oxygen. Nascent oxygen will oxidize the red paper or any color paper to white. It is a bleaching agent, it bleaches. Chlorine is a bleaching agent. So the final thing is the paper will turn white. So 2 observations possible. When blue litmus paper is introduced to chlorine, the paper first turns red and then turns white. I think it's clear. Next question. A piece of moist red litmus paper is placed in a jar of ammonia. Nothing but red litmus turns blue. Red litmus turns blue. Alkaline nature of ammonia. Silver nitrate solution is added to dilute hydrochloric acid. Curdy white PPT. Dilute HCl contains Cl minus ions and H plus ion. Chloride ions are there, so curdy white PPT, right? Then zinc oxide is heated. This we know already. It turns yellow when hot and white when cold. This is something that important to note. Zinc oxide is yellow when hot, white when cold. It is heated. Okay. The next question that is possible is ammonium hydroxide solution is added to copper 2 sulfate solution. Slowly drop by drop with shaking till it is in excess. Here again what happens, pale or whitish blue PPT formed. First thing is that. Second thing is the PPT precipitate dissolves in excess of NH4OH to give deep or inky blue solution. Okay, two observations possible. We already know, we have discussed it previously. Now solution A contains sulfite ions. Solution B contains sulfate ions. How will you differentiate between them? Using chemical test. This already I have discussed in the anions test. Now here let us see what we will do. Add test number of differentiate. So there will be three parts in the answer. First part is add barium chloride solution. Barium chloride solution to both. Yes. Then add dilute HCl. Okay, to both. दो reagent है. Two reagents, first barium chloride and then dilute hydrochloric acid. Now first observation, what is the observation on the first one? That is sulfite ions. If it is sulfite ions, what will happen? It will give white PPT. White PPT formed. Then PPT dissolves in dilute HCl. Okay. Then if it is sulfate ions, what you will write? White PPT formed, white precipitate formed. Yes, full stop. The PPT does not dissolve in dilute HCl. So the solubility in dilute HCl is what differentiates them, right? I think that is clear. Now how do you complete this table? Copy and complete the table. Another type of question. Solution is here. The various solutions. Then effect of adding sodium hydroxide, effect of adding ammonium hydroxide. We have discussed already these things. Small quantities in excess. Okay. Calcium nitrate. So the test is only identifying the alkalis are added. So the cation is being tested here. So calcium ions adding sodium hydroxide. Small quantity, white PPT. What is formed? White PPT. In excess, PPT does not dissolve. Yes, we know that. Then here, no PPT and no change. This is already given in the question. Only this part is to be filled, right? Now, zinc nitrate solution. Zinc ions are there. What happens here? White PPT comes in sodium hydroxide. White PPT. And in excess, what happens? PPT dissolves. You have to differentiate, right? Then in the case of ammonium hydroxide, same thing happens here also. White PPT is formed and here the PPT dissolves, right? Then if it is lead nitrate solution, the lead ions are present, Pp++ ions. Here you get white PPT, sodium hydroxide. Here you have PPT dissolves, excess of sodium hydroxide. In ammonium hydroxide, you again get white PPT, and here PPT does not dissolve. That makes the difference. Does not dissolve. Okay. I think this is very clear to you. So you can watch the video again to solve the questions once again. You may write these questions in your notebook and solve. That way you can practice. And if you have questions, you can also ask me. Okay, you can send questions. So students, I hope you understood this, and keep solving these questions so that you will be able to answer your paper well. Now you can subscribe the channel so that you will see my upcoming videos. In the next series, I will be starting hydrogen chloride or hydrochloric acid. Thank you.